In Chapter 8, we will be studying the exponents and exponential functions. 8.1 starts with the multiplication properties of exponents. To multiply two powers that have the same base, you add exponents. So here's an example. We have a squared times a cubed. Because the base is the same, a, we could simply say that as a times a times a times a times a. If we did that, we would see that there are 5 a's, giving us a to the 5th power, or we could look at the 2 factors in the first a and add those to the 3 factors in the second a, giving us the same results, a to the 5th power. To find a power of a power, you multiply exponents. Here is an example of that. A squared and that quantity cubed. So there are 3 factors, a squared, a squared, a squared, which equals a times a times a times a times a times a, resulting in 6 factors, a to the 6th. A simpler way, we could do a squared times the power that's cubing it, so a squared times 3 equals a to the 6th. These two rules for exponents and the rules for raising a product to a power are summarized on the next screen. So let's go ahead and put these properties to action here. We have 5 cubed multiplied by 5 to the 6th. Our base is the same, they're both 5s, so we can simply say 5 and we can say cubed plus to the 6th, giving us again the same base, 5 to the 9th. The same holds true for variables. We have x squared times x cubed times x to the 4th. So we could take the base x and all of the exponents and add them. 2 plus 3 plus 4. Our base stays the same, x, and our exponent changes to 9. In letter C, we will have a multiplication statement. However, the base is the same, 3 times 3 to the 5th. 3, and it was an implied to the 1st power, times 3 to the 5th power. Bases are the same, so it would stay as 3, and we would add 1 plus 5, the exponents, giving us 3 to the 6th. And the same holds true for letter D. We have the base of -2. The first one is -2 to the 1st, that's implied, times -2 to the 4th. So we have the base again, -2, and that would be 1 plus 4. So that would be -2 to the 5th. Now, example 2 talks about using the power of a power property. So we have 3 to the 5th, and we want that to be squared. So we have the base 3, and this time we're going to multiply our exponents, 5 times 2, because this is a power of a power. That way we get 3 to the 10th. Again, our base in letter B is y squared to the 4th. So we have the same base, y squared times the 4th, so y to the 8th. In letter C, we have -3 cubed, and we want that to be squared. Remember to keep your base -3, and then we'll go ahead and put our exponents. That was cubed and then squared. So our base stays the same, -3, and 3 times 2 is 6. Letter D is slightly different. We actually have an equation, a plus 1 squared, and that's going to be our base. Notice a plus 1, and it's squared, and then to the 5th. Those are our exponents, and we're going to multiply them. Keep the base a plus 1 to the 10th. When you use the power of a power property, it is the quantity within the parentheses that is raised to the power, not the individual terms. Make sure that you realize the difference there. So in example 3, they're going to give us some practice in this. Using the power of a product property. So this time we have 6 times 5 squared. Okay, again, it is the quantity within the parentheses, which is 6 times 5, that is squared. So when we do that, we're going to go ahead and we're going to say, we're going to first evaluate each power and then we're going to multiply. So 6 squared is 36 times 25, 5 squared, and 36 times 25 gives us 900. Let's try that again with a couple other examples. 4yz cubed would be 4 times y times z, that quantity cubed. Again, our first step would be raise each factor to a power, and then we're going to simplify. So we'll say 4 cubed times y cubed times z cubed. We can go ahead and multiply out or simplify 4 cubed to 64, and then we can take out our multiplication symbols, and it would be 64y cubed z cubed in its simplest form. In the next one, we have negative 2w squared. So that's a quantity in there, negative 2 times w squared. We're going to go ahead and raise each factor to the power and simplify, same as above. So that would be negative 2 squared times w squared. Remember your rules for exponents with negatives. Negative 2 times negative 2 would give you a positive 4. So that's 4w squared in its simplest form. And I think we have time for one more. This time, notice the negative symbol is outside the parentheses. So we have 2w in the parentheses squared. That would equal the negative or opposite of the quantity 2 times w, and that is squared. So we want to raise each factor to a power and then simplify. So when you do that, you would have 2 squared times w squared, and the opposite of that value, so that would give you negative 4w squared.